Very good morning to one and all. This is Dr. B. Santanakrishnan, Associate Professor, Department of Electrical Engineering, GC Bodina Ignore. And this slide was prepared by myself and Dr. B. Paramasim, Associate Professor, and Dr. S. Ramesh Kumar, Associate Professor from Department of EEE, Government College of Engineering, Bodina. In previous model, we are discussing about the first unit. This model, we are going to discuss about the second unit. Second unit, it can introduction to AC circuit. So AC circuit consists of a combination of circuit elements and power sources. The power sources provides an alternating voltage delta V. Delta V, the lowercase symbol will indicate the instantaneous value. Capital letters will indicate the fixed value. So AC voltage, the output of the AC power source is sinusoidal and they varies with the time according to the following equation. Delta V equal to delta V maximum sin omega t. Delta V is small delta V is the instantaneous voltage. Then capital delta max is the maximum output voltage from the source and also called as the voltage amplitude, and omega is the angular frequency of the AC voltage. So the current in the AC circuit driven by AC source is an alternating current that varies sinusoidally with the time. Commercial electrical power plants in India use frequency of 50 Hz. So AC voltage, this is the diagram of AC voltage. The angular frequency omega equal to 2 pi f equal to 2 pi 1 by t, because f is inversely proportional to the time. F is the frequency of the source and t is the period of the source. The voltage is positive during the one half cycle of the cycle and negative during the other half cycle. You can see the waveform. One is the positive half cycle, other one is the negative half cycle. From positive, the peak of the positive half cycle to another peak of the negative half cycle considered to be a one cycle, generally called as the total time T. See, AC fundamental. Previously, we learned that the DC source have fixed polarity and constant magnitude and thus produces current with constant value and unchanging direction. In case of DC, it is only a unidirectional. You can able to send the power from one side to another side. But you can see the diagram. We have a DC voltage. We can connect it with a resistor. You can see the diagram. There is a diagram. The voltage is always constant. It's only one direction. Only one direction. In contrast, the voltage of AC source alternate in polarity and vary in the magnitude, and thus it produces current that varies in magnitude and alternate direction. You can see here it is a positive half cycle. It starts with 0, it goes to the maximum value, positive maximum, then it comes to 0, then it go to the negative maximum, then it comes to 0. So the peak is, this is considered to be a one cycle consisting of one positive half cycle, one negative half cycle. Then sinusoidal, generally, so if you are continuing, it is generally called as the AC signal. It alternatively the positive half cycle, negative half cycle, it continues look like a sinusoidal waveform, sinusoidal vehicle. So one complete variation of referred to as a cycle. Starting at 0, the voltage increases to the positive peak value and decreases to 0, changes polarity, increases to negative peak value, and then again it coming back to 0. Since the waveform repeat itself at a regular interval, it is called as a periodic signal. Symbol of AC voltage source, you can see from the diagram, you can show the symbol of AC voltage. Lowercase letter is used to indicate the value varies with the time. Generally, I told you a lowercase value is generally so instantaneous with the instantaneous value of the corresponding AC voltage or AC current. Then if you go for capital, it is a fixed value of the AC voltage, AC current. Then sinusoidal AC current. During the first half cycle, the voltage source is positive, therefore the current is in the clockwise direction. During the second half cycle, the voltage is reversed, therefore the current is also in counterclockwise direction. Since the current is proportional to voltage, its shape is also sinusoidal. So the voltage and currents are equal in case of a resistive load. In case of a pure resistive load, the voltage and currents are equal generally. So the voltage and currents are same shape. The voltage also sinusoidal shape and current also sinusoidal shape. From the diagram, we can easily understand the waveform of voltage and current. Then how to generate the AC voltage? So if any electrical conductor placed with a magnetic field, automatically it start to rotate. It cut the magnetic flux. There is a flux linkage between the north pole and south pole. If you place an electrical conductor between the magnetic field, automatically it start to rotate. The direction of rotating decide the polarity of the generation of the AC voltage or AC current. If you rotate in clockwise direction, the polarity is positive. If you rotate in anti-clockwise direction, the polarity is negative. From the diagram, you can easily understand it is going to be a positive direction. The two north pole and south pole magnets are given. The conductor is placed between it. There is a magnetic flux linkage between the two north pole and south pole. One electric conductor is placed, one electrical conductor is placed between the magnetic field, then the conductor start to rotate. The magnitude of the resulting voltage is proportional to the rate at which flux lines are cut. The polarity is dependent on the direction of coil side move through the field. So generating AC voltage, since the coil rotates continuously, the voltage produces will be high. So time scale, often we need to scale of the output voltage in time. The length of the time required to generate one cycle depends upon the velocity of the rotation. So 600 revolution in 1 minute, for example, you can take 600 revolution in 1 minute. So 600 revolution by 60 seconds, and that is equal to 10 revolution in 1 second. So the time in one revolution equal to 1/10 of the second, that is the 100 millisecond. From the diagram you can easily understand 0 to 50 and 50 to 100 is considered to be a one cycle. Voltage and current conversion of the AC. So first we assign the reference polarity of the source and the reference direction of the current. First we have to assign the reference polarity of the source, whether it is a positive direction, whether it's a negative. So once you assign the reference polarity, then we can convert the positive. Then we can convert the voltage and we can say whether it is a positive voltage, whether it's a negative voltage. For similarly, we can go for the same. For the current, we use the conversion that when I has a positive value, it actually direction is same as the reference arrow, and when the I has a negative value and it is actually direction opposite to the reference value. You can see from the diagram. The voltage and current are the same. The positive voltage means there is a positive current. If the negative voltage means there is a negative current. So there is a circuit is given here. One AC voltage is connected with a series with a resistance R. The upper side is positive and lower side is negative. Generally, the positive and negative should not be mentioned in case of AC, because positive and negative should be mentioned only in case of DC. Because of understanding of the current flowing of current direction, we are going to mention the positive. If the positive means the current voltage and currents are positive, if the negative means the voltage and currents are negative. Then the time period T, the waveform is duration of one cycle. The total T is nothing but one full cycle. The R peak to peak value, or it start from 0, again it comes to 0, again it start to again it comes to 0. So there is a 3 zero crossing point in one cycle, one full cycle. So T equal to 1 by F, that is called frequency. That should be measured in second. The period of waveform can be measured between any two corresponding points. Often it is measured between 0 points because they are easy to establish an oscillation of traces. From the diagram you can easily understand it, how the frequency or the time period is going to be calculated. Then phasor diagram. The phasor is a rotating line which projection of a vertical axis can be used to represent sinusoidally varying quantities. To get an idea, consider the red line of length Vm shown in figure. The vertical projection of this line indicated dotted red is V equal to Vm sin alpha. By assuming that the phasor rotates the angular velocity omega radian per second in the counterclockwise direction, you can see here there is a red line, V equal to V sin omega t. From the figure we can easily understand the phasor diagram of the phasor diagram. The phasor diagram is nothing but we can dotted circle. Then we have arrow mark with anti-clockwise direction. So this is about the basic of electric AC voltage. Introduction to AC circuit. We must know what is called voltage. We must know what is called current, what is called frequency, and what is called time period. In next slides we are going to discuss about the further in your second unit.